Hello, can you all hear me? Yes, I think so, right? Good evening to you, all of you. I hope you are all having fun. Are you? Yeah, on an evening, right, in Las Vegas, right, you just want to get through this whole thing and then you have more fun after, right? But anyways, if you are building agentic AI applications and you're really struggling with your applications in terms of, lacking context or these models hallucinating, right? You are in the right place to discuss that. And that's precisely what we're going to discuss. This is Srini Pendiala. I am the Senior Partner Solutions Architect here at AWS. And I'm joined by our esteemed partner, Elastic, represented by Uday.
Yes.
And more even exciting is that we actually have our joint customer in the form of Tavily, and represented by none other than the CEO himself, Rotten. And we are all going to, together, help further go on this discussion of context engineering and how we can better build quality agents for our enterprise needs. Yeah? Thank you so much for your audience on this, and really please accept our gratitude on this. And gentlemen, if I may request, and then as they come onto the stage, they'll introduce themselves too. Perfect. So, technology, yeah. I want to take one step back, right? Take a deep breath and talk about AI agents, right? We at AWS clearly thought through this and then gave a definition for this. And it's basically AI agents are autonomous or semi-autonomous software systems that can A, reason, B, they can plan, and C, they can actually act to accomplish specific goals or the tasks that you're giving and throwing at them, right? In essence, that's what an AI agent is all about. Now, for these AI agents to be able to do their job, they need many things. Things like, for example, if you want to accomplish something, right, you need a crystal clear definition of what the task that you want to achieve. Then you also need tools, right, to do those tasks. And AI agents are no different. And we're going to zoom on to that in a second. Now, why are we talking about the AI agents here? Because context engineering or building agentic AI applications with the right context, specifically your business context, is so crucial. Otherwise, these models, at the end of the day, they're just models. They don't know what to do unless you give them the guidance, unless you give them the right context, especially in an enterprise setup. You have these data sets. Rather than saying data sets, I would want to call it as data assets. That's your IP. That's your data. And only as much of the quality of the data that you actually provide as a context to these agents, only so much you can actually get out of it, right? So if it's garbage in, garbage out. But if you provide quality data, you get quality output. Technology again, sorry. Yeah, there you go. I think I probably need to eat more. So, as the numbers speak, AI revolution is happening. These are the numbers from the Gartner themselves, right? They are saying by 2028, 1/3 of the enterprise applications are already using agentic AI in some form or the other, right? And at least 15% of the actual decisions would be made by these with the help of these agentic AIs in a typical enterprise too. And again, that's by 2028. These are the numbers that's directly coming off the Gartner reports, research. So, what that brings us to, we want AWS to be the best place to build and deploy the world's most trusted and useful agents. That's the vision that we have. And we would love to always collaborate with our partners like Elastic to actually make that a reality for our customers. Now, the story starts, let's actually take one more step back again and look at it from the choice of the framework itself. Purely from the developer's standpoint, right? You have many agentic AI frameworks like LangChain, LlamaIndex, Crew AI. Anybody used Crew AI? Anyone here? LangChain? LangGraph, yeah, there you go, sir. I see a few hands, right? These are all great frameworks, no doubt. AWS also took one step back and created another framework, SDK, called Strands Agents. It's completely open source. It's written in Python, right? Any Python lovers? There you go, I see a lot of hands. Yeah. You're going to feel super, super easy at home with Strands SDK, right? Let's say, what is the end of the day? What do you need to create an agent, right? It actually requires 3 components. 3. Number 1, it requires a task. Throw a task at it, what you want to accomplish, right? Typically, that translates into a system prompt that you actually throw at it. The second thing that it needs is, obviously, like I said, tools. So you take your existing APIs, you take existing application logic that you already have, and with simple decorators or annotations, you can actually convert them into tools that your agentic AI applications can actually leverage, right? And the third thing that you need is, obviously, the foundation models themselves. And where do you get this from? Where do you get these foundation models from? Again, Amazon Bedrock actually has a plethora of foundation models from all the AI innovators like Meta, Anthropic, even Amazon itself, right? So bring all these things together with Strands SDK, and believe it or not, developers are going to love this. The experience is going to be super simple, super simple. It's actually one line of code. It's really one line of code to actually craft an agent with all these 3 ingredients: system prompt, foundation model, and the tools. It's just one line, right? So it's that. If I fell in love with Strands, of course I've got my hands dirty on the other frameworks too. Nothing against them, but this is another choice for developers too. So at AWS, we give all the tools that you need to really make this AI adoption, which could be a utopian dream, a reality, right? So at the very top, you actually have ready to use, right out of the box, ready to use solutions in the form of, like, for example, for your enterprise productivity, we're talking about Amazon Quick Suite or Quick Suite, whatever, right? You have Keto for agentic software development, right? You have AWS. If you have legacy systems that you want to quickly migrate them, as they used to talk about app modernization, now we're talking about AI modernization. So if you want to do that, you have AWS Transform, right? This is all great, but then if you want to do yourself, if you want to craft these applications yourself, again, for the developers, I already zoomed in on this, which is in the form of Strands agents. That's another SDK that you can actually leverage. And then, if you want to really do this in your own DIY style, then of course, the Amazon Bedrock itself becoming the foundation actually gives you the model choices, like I already mentioned, right? Then it also gives you the capabilities of, for example, you want to do it in a more responsible way. You don't want to, leak information that should not get into the wrong hands, right? You have the guardrails for that. And this is all great. It all looks super easy on a developer laptop for a demo, for a POC. It's all great. But then as soon as you decide to actually move your agentic AI applications into a enterprise scale production deployment, right? Then it's not going to be easier, as we all know, right? You got to think about security. You got to think about how do I manage, where do I in fact run these AI agents in the first place, right? You need a runtime environment for that. You need to manage the contextual memory, right? In the form of short-term memory, in terms of the long-term memory, right? You need to think about enterprise AI adoption requires enterprise security too. Authentication, authorization, all of that. So the answer from AWS on that aspect of to quickly make it easy for our customers to do this comes in the form of Amazon Bedrock AgentCore. And I'm going to zoom into that in a bit. And of course, if you want to do the traditional AML, we have Amazon SageMaker itself. You can do custom models building right from that. You can train them with your own data. You can even leverage for your training purposes, you can actually leverage Trainium or Inferencia and GPUs and all of that on Amazon. So you have a plethora of options here. Do it yourself, ready-to-use solutions, or even go deep dive. You have plenty of options here. Now, like I said, building an agent is the start. Doing POCs is easy. Getting excited is easy. But then production scale is the goal, right? You want to run these things so that your enterprise can actually adopt, discover these agents, and then get the job done. That's where, like I said, Bedrock AgentCore is of help. In essence, what we're talking about is we would want to, undifferentiated heavy lifting of your AI operations. We want to take that on our shoulders so that you can actually focus on your innovation, so that you can actually focus on your business applications, so that you can actually focus on your application use cases and application logic itself, while we do the rest of the stuff for you, right? So it comes in this, it comes in the form of, it's basically Amazon AgentCore is a combination of these modular services. We're talking about runtime, we're talking about the memory, we're talking about identity, gateway, and of course the other miscellaneous tools too. So let's actually zoom in to each of these, right? The foundational service for running these agents actually start with the runtime itself, right? So you need a place to run these. That's where AgentCore runtime comes into the picture. And basically, think of like good old days, a serverless compute environment for you to run your serverless computations, right? Same thing here. If you want to run your agentic AI applications, you need a runtime environment. That comes in the form of AgentCore runtime. And when you do that, you also need to be able to do this in a more secured way. Who can access your data assets? Who can access these agents? Who can do what? The authentication, the authorization aspect of it comes in the form of identity, right? You need a strong identity services to be able to tie it up with your actual agents so that you can actually securely run these agents. Similarly, if you want to, we also provide the tools to enhance the overall experience, but the needs, of course, these are the actual fundamental needs of an agentic AI application itself, right? You need memory. You need, developing these AI agents is one aspect of it, making them discoverable across your enterprise so that the rest of the other agentic AI applications within your enterprise can also take advantage of it. If you go back a decade, 15 years back, right, when this whole notion of API first strategy started, right? We were building API bus so that these APIs can actually become discoverable within your enterprise, right? Same thing here. As you build agentic AI applications, you want them to be discoverable. You want them to be used. Otherwise, what is the use of building super fancy agents, but nobody knows that they even exist? That's where the gateway comes into the picture, right? And of course, if you want to simulate user actions using web tools, you have the browser tool. If you want to automate workflows using software, you actually have the code interpreter to do. So long story short, they all come together, right, to make your agentic AI applications enterprise ready. And we're doing this completely. It embraces any framework on the planet, literally. Okay, most of the famous ones, the Crew AI, LangGraph, Llama Index, or our own agentic AI, Strands agent itself. So you can use any of these frameworks. You have a strong affinity to any of the protocols, like whether it's MCP or A2A. Please bring it on. The idea is that we want your agentic AI application super easy to be deployed on AgentCore, and that's the goal here. Right, so I want to quickly mention something here real quick. In New York Summit, right, last summer, Elastic has an MCP offering. If you haven't tried it, you should get your hands dirty. It's super easy to use. So we announced together, Elastic and ourselves, we actually announced And Elastic is one of the esteemed partners who actually went and GA'd their MCP offering on AgentCore runtime. What does that mean to you? If you already have your enterprise assets that are indexed in Elastic, with simple natural language, you can actually interact with the data using the MCP server on AgentCore securely. Makes super easy for you to craft these AgentCore applications using Elastic as the data source. Next is about the AgentCore gateway, memory, and browser. So now, I didn't actually zoom in on this one, right? AgentCore memory is a crucial, important ingredient, specifically in the context of actually context engineering itself, right? You want to manage here the memory of the information that you're actually feeding to your models for your agents. There is short-term memory, there's long-term memory. I'm very happy to again share with you all that we, using Strands SDK, with one single API call, you can, if you already have Elastic, right? You can, one single API call, you can actually use Elastic as your data source for agentic memory. One line, completely manages it for you. Developers love that. More importantly, business users also love it because you're actually shipping code much faster. Your value to your time to value is shorter, so you can actually reap the benefits of your investments, right? So, and the third thing is, yeah, this is my favorite. I was actually, myself and Uday, we actually got our hands dirty a couple of days back to make sure actually this actually works, and it does, because AgentCore observability module, right out of the box, with zero code, with auto instrumentation, emits OTel, open telemetry data. And Elastic also being in the forefront of open telemetry, they actually, in fact, they have their, Elastic actually has their own distributed open telemetry contributions. It's called EDOT. I'm sure majority of you are already aware of it. So with open telemetry data, right out of the box, with zero code, Elastic can actually give you end-to-end, right from the time the agent actually gets invoked, all the way to the end that you get the final response. You can actually collect the logs, you can actually collect the metrics, you can actually collect even the traces, and see for yourself what's happening. It's basically, it's one thing to have these, but it's another thing to actually observe this, right? So AgentCore observability works right out of the box. And if you want to go more fancier, if you want to expand these traces with more custom spans, you can also do that using your custom instrumentation logic too. So that's again a possibility with Elastic. So Elastic today, in summary, is in the AgentCore runtime using their MCP offering. They are directly plugged into Strands SDK as a long-term and short-term memory. And then best of all, everything is that you can actually observe right out of the box, again, with zero code, practically, the end-to-end of all of your agentic AI applications. So I love Elastic, and I'm not doing this as a lip service. I really love this because I have seen our customers actually reaping the benefits of this technology. So that's observability, right? We already talked about it. In essence, that's Amazon Bedrock AgentCore. You have all the tools that you need to really deploy your agentic AI applications at enterprise scale. And we do that by being very open to MCP, being very open to A2A, any kind of protocol that you subscribe to. And of course, we love any framework that you can bring onto this. As long as you can actually containerize your agentic AI applications, the doors are open for you, right? And Elastic, if you use Elastic as a data source, the game is super easy for you all. So with that, I would like to take a pause here, and I would like to request you all, if you want to get some inspiration, get some motivation, some impetus, please take a snapshot of these resources. I want to leave this with this idea here. Agentic AI revolution is happening. There is no more, it's an option for us to be part of it or not. It is happening. And it's super easy. I would like to very humbly challenge each and every one of you to think big, innovate, and use these tools. Strands SDK is super easy to adopt. And then you can easily bring your workloads to AgentCore. And if you're not believing it, one of these, the SDK and the tools and the samples, especially the samples thing that you're looking at, is actually going to point to a GitHub repo. You got all the plethora of samples that you can actually look at, get inspired, and then build your own. Make AI dream a reality. And with that, I would like to actually invite Uday from Elastic. And Elastic has been doing a lot of innovation in the space of context engineering. So I'd like to have him, further double click on that. So, thank you so much. Appreciate it.
This is the next slide. Hi guys, you're able to hear me? My name is Uday Thipireddy. I'm a cloud architect at Elastic covering AWS solutions. I closely work with Srinivas to solve the complex problems. So that's my job. Actually, you know Elasticsearch already because Elasticsearch is pretty popular as an elk stack, right? So Elastic Log Stack is Kibana. So you may be used in log analytics, maybe security observability in somewhere in the shape. So, but Elasticsearch is a very, very popular vector database. So it's like it's most popular vector database is downloaded in the last 1 year. It's like 5 billion downloads. So it's like pretty popular vector database. 50% of the Fortune 500 companies are using for different use cases. So we have a platform, Elasticsearch platform, and we have solutions on top of the platform like observability and security. So we have integrated all the AI things in AgentCore, strands, and also Bedrock inference and everything part of the Elasticsearch. You can run Elasticsearch in your laptop, in cloud, as a serverless offering. So we are giving that option because you can deploy it anywhere. So you can run in a container. It's up to you basically. But most easy way to run is a serverless offering. That's on Elastic on AWS serverless. So if you maybe you used Elastic in some way, other way, use cases wise, maybe you took an Uber from your hotel to Venetian to attend the session. Are you checking the restaurants in Yelp to get some good food in the evening to get relaxed day? So you are using Elastic in many ways. Like maybe you're searching for say, your date like Tinder. So it's just many ways. It's like search, wherever the search is there, Elastic is there. So I know Elastic started a AI journey almost a decade ago. So if it's not AI is AI ML is like a big platform. So when we started AI in a log analytics or security detecting the anomalies, so we started with the supervised and unsupervised machine learning. So machine learning is basically, we use the machine learning to detect the anomalies. We use the machine learning to detect the algorithm, all that clustering and all these things in last decade. So we know machine learning very well. We give that as a value to all the solutions. So for the phase one, right? So after machine learning, all this like models and everything. So recently the LLM explosion came. So everybody started using foundation model. As Srini mentioned, there's like a lot of foundation models like Anthropic, Nova. There are like plenty of foundation models from Amazon and even like some of the other third party like 12 Labs and a lot of people using different models for different use case. So the models are great. So there's no issue with the model, but only thing is that models have some kind of a memory that only works for 80% of the time it's accurate. So the second use case is RAG. So if you are working with your enterprise applications, like maybe banking or like finance, maybe anything with the insurance, right? So you have to store those vectors somewhere in, retrieval augmented generation that's in Elastic, right? So that's a RAG use case. If you ever use a chatbot application, maybe booking travel or like, calling the customer care. So that will go to the RAG system nowadays. Everybody is building that. So behind the scenes, like RAG uses vector database to basically give the prompt to, make it like a context aware prompt. That's where RAG comes into picture. We have the vector database that inbuilt the models. We have ELSER and S3 and some other models. You can bring your own model also, custom models. But RAG is pretty popular use case. Elastic do RAG very, very, frequently. That's another. And then also moving to the agentic one. So more and more Elastic use cases are increasing because Elastic as a long-term memory, as Srini mentioned that in strands, right? So Elastic work as a long-term memory because in enterprise-grade applications you are building, so you need a security, you need a scale, you need a reliability, you need durability. It's not easy to basically build in a laptop or like in a container, right? So that Elastic provides that long-term memory and the agentic memory. So that's, and then also if you look at the same content, but it's a different way, RAG, if you user fire the question, but that will go to the Elastic, check the context first, and that context may be coming from your email, a Word docs, maybe Google Docs, all that vectors you're storing. So if you are getting that context from vector database and giving that prompt to LLM, then you most probably get 99% of the correct context, right? So otherwise, LLM thinks, if you think, example, like if I put it like a NASA, so with NASA, maybe that's like a, popular, airspace, like a, engine like this. We look at like NASA is, in Elastic context, it's like a North American sales organization. So something like you don't know the context wise. So basically, if you think about that, so the context is important for getting the right answer from LLM. So LLM cannot give that right answer by itself because it needs, because all these LLMs trained by the reinforced learning. So it gives right answer over the time, but it won't give the right answer the first time. But in the business, you cannot wait for the right answer because once you get the wrong answer, your customer may not come back to your website, may not use your app. So that's where you have to be very, very careful building this application with enterprise grade. That's a RAG. The second thing is the same thing, it's the agentic AI. So you need a right memory because your LLM cannot remember everything because it's just only 50-60% of the time. And then after that, you have to rely on the long-term memory because we're talking about petabytes of data. It's not like terabytes of nowadays. Data is like exploding. If you use in a right context and right data, so then you will go next level to the in your competition. So the next hype in the AI. So AI is not a hype, but I'm just saying like a lot of people are thinking it's hype, but it's real. But if you build it correctly, only thing is that AI will come up with their own challenges. The next AI is coming, the autonomous cars or maybe robotics, something like that, maybe humanoid robots. For that also, they need data to operate. If you put like your workflows, your tools and your agents with the right context and right data, then only it works as expected. So the challenges with agent is basically the lack of context. So the lack of context is same thing, right? Srini mentioned that even traditional AI, right? If you don't give a right data set, right inputs, and you won't get right output. Same thing for the Gen AI, agentic AI. That's a lack of context will give very bad experience to your customer. So that's where you need a lack of context and also durability. If you have a context, you have everything, but you don't have a security, you don't have a right system, then it will fail because you need that durability inbuilt in the system, right? So that's where Elastic provides. And 95% of the POCs fails because of this, because you don't have a lack of context. And context window is you're not setting the right context, then you won't get right answers. Simple analogy is basically GPS. Even if you enter a wrong address in GPS prompt, you will end up somewhere else, right? So even your car is good, your GPS is good, it's the same thing. Your LLM is good, your compute is good, but still you're getting a wrong address. So that's where like you need a right context window and you need a enterprise clean data. Clean data means your data quality and data governance, everything is like you have to create that in a enterprise grade databases like Elastic. So all of the tools like MCP, like Srini mentioned, and MCP is great, but only it can communicate with other agents. It can get the data, but only thing is you have to massage the data. You have to clean the data. You have to put it like the data in a format. Even the agents understand, the Gen AI application understands. So that's where that enterprise grade up, data stores like Elastic comes into picture. And same thing with the complex, fragile development. That if you build that app, a Gen AI app or agentic app in a rush without using all this guardrails or right data store, then you end up managing that. You cannot operationalize that agent in the market. So that's the problem with. So Elastic is one-stop shop for everything. It provides all the encoding models inbuilt. It's sparse encoding model, dense encoding model, and multilingual embedding models like E5. So all that is, you don't have to work on the undifferentiated heavy lifting in the data store. So it comes with it. I know some of the data stores, you have to build your pipelines. You have to work with external models, do your chunking strategy, build your embeddings. All that you have to manually do it. That's like it's not easy because you have your day job and you are managing that, all that yourself is like, it's time taking. So multi-modal embedding models, like we have multi-modals like, text, maybe audio, video. So those are all supported. And GPU-based inference. If we have automatically included GPU-based inferencing, and we have tight support with Amazon Bedrock, Anthropic models. We have tight support with other models like SageMaker. If you want to open source model inferencing, you can still do with Elastic inferencing with SageMaker. So that's all possible. And like I said, chunking is part of that. We have close to 200 plus connectors. The data onboarding is easy. So you don't have to build that in the pipeline. We have that APIs built. We have all that taken care. So you don't have to work to get the Salesforce data or like some other data from in a Google Drive. All that is part of the Elastic, and all the web crawlers built in. You don't have to work on the web crawler stuff. So everything is part of that. And we do auto parsing. And now that we are using AI to parse your data, put it in a right format so that it's clean, it understands the data. So the retrieval side, it's like more on the vector search. You can do vector search, you can do lexical search, you can do hybrid search. All that is possible. And in fact, you can also do geospatial and graph retrieval also. And then, like I said, we have our own models. Like we recently bought a Gina model that from recently acquired a Gina company that's come up with a re-ranking models, very popular in the industry. So it's taken care of the re-ranking, and it gives the relevance to context. So that's another one. So we are innovating behalf of you, so you don't have to do heavy lifting. And it can work with the RAG workflows and LLM integration. All that is part. Now we are moving to agentic side. So we actually recently released the agent builder. So that is actually provides agentic workflows, and you can build tool selections, and all that is part of the prompt. So that's just a thing. Another thing is Srini mentioned, once you build it right, you need to monitor that. So that agentic observability is a key one. So we recently integrated with AgentCore observability. You can monitor agents, invocation logs, error logs, and agentic memory, because GPUs are very expensive. If you're not careful with the GPU consumption, you end up with maybe millions of dollars, right? So you have to optimize your GPU. So that's where Elastic comes into picture to show you how many tokens you're using, what kind of invocation lags, your agent-to-agent communication, everything is part of that. So we also do all this token tracing and everything like. So next one. So this is the agent builder. So we recently launched. It will provide agentic applications building very easy, because you have a data sitting in Elasticsearch that is already clean, and then also it provides the right context to your LLM and agentic stuff. So that's where like you can chat with your data. You don't have to write complex SQLs, joins. All that is like natural language processing. You can chat with your data as if you're talking to human. So that's easy that we make it. And then also custom, if you want to customize the tool or workflow, you can do that with eSQL. You can actually define the workflows. You can do that, how you can control that agentic flow. You can define that in a custom tool. You can attach to the agent, and that will manage your flow. And we have external integrations like MCP, and Amazon released their own MCP server, right? So you can talk to other tools and other agents, like maybe SRE agent or something like a security agent, you can build with that, and maybe you can build a financial services agent. So it's endless opportunities, and opportunities are limitless. You can try anything, but that's and like I said, if you look at this Venn diagram, like context engineering and agent builder, Elasticsearch in between. So it can provide all that ingestion, data onboarding, and security, re-ranking, all that enterprise level grade data store it'll support. And an agent builder will build the custom agents for you if you want to, because that POC to production, everybody can build the POC apps. But if you want to build a production ready and POC to production, that's where Elastic gives that easy way. It builds powerful custom tools. You can build you can easily check your agentic app right there. So the agentic builder is basically provides the accelerated agent building. That's what I said. You can build instead of going months and months, you can try within like days. That's possible. And then you can customize the workflows. You can actually do native context engineering and build a reliable AI development, right? So this like, it'll come up with, because privacy is very important in agent building. So if you build without a privacy, there's no point, right? Because industry comes with all this governance, maybe the HIPAA or like SOX. We have to manage this data in a correct manner. Otherwise, you may end up like getting bad experience from your customers. So that's the thing. And with that, I will actually hand it over to Rotam. He will show you how he built agents, real agents in the industry with the Elastic and Amazon services. Thank you very much.
All right. Hi, everyone. Excited to be here. It's my first reInvent, so also interesting. Yeah. Right. What we're going to do today, I'm going to introduce Tavily, because I think not all of you know what Tavily is. I hope you do. Then we're going to do a dive into what context engineering is. More practical, I'm going to show you some concepts and things that you can just take home and do. And then we're going to finish it up. Hopefully, we're going to have time with a very simple demo. It's just going to show how you utilize all of the technologies that were mentioned, Elastic, AWS, and also Tavily, to build a very simple sales agent. It's simple, not because I was lazy. It's simple because we have great technologies that reduces a lot of time to developers. Awesome. So what Tavily is. If you think about the shift that is happening today, up to now, people used to communicate to the web directly, right? You would go on Google, you're gonna send emails, but what's happening right now with AI agents is that people communicate to agents and they communicate to the web. What it means for companies is that we're becoming this gateway for everything that's gonna go in and out from the organization. And that requires a lot of governance, security. They see it as the new firewall. And obviously scalability to really allow them to build all of their agentic system and connect them to the internet with Tavily. Who knows Tavily here? Anyone? Perfect. Awesome. So what it started with is really, if you think about a year ago, you'd ask any LLM or ChatGPT, you would ask, what's the weather today, or what's the score of the game last night? And the result you would get, as all of us know, is, hey, my knowledge is cut off to 2021, I cannot answer that. So that was the first thing that we kind of bridged. That was the gap. But it turned to be much more complex, right? It turned to be much more complex because it's not all about getting the right knowledge. It's really going into the web pages and extract the right snippets. And now when we're going to talk about context engineering, you're going to understand why it's so complex, but also so important. Awesome. So what context engineering is, we talked about it before, but I'm going to recap. It's really what you put inside a context window. And it's what you put inside a context window at each step. So we have knowledge, which can be your proprietary data. It can also be your emails, your Slack, maybe web knowledge. You have tools, like the Tavily tool. Maybe it's going to be a calculator that's going to do calculation and return the agent some feedback, and instruction, which is prompt engineering. It's really to give you the tool descriptions. It's to tell the agent exactly what you want to achieve, give it some restrictions. Each one of them is an art by itself. Awesome. So this is very important because you're going to hear a lot context engineering or context window equals RAM, which kind of makes sense because it's really you want to put inside a context window what's going to allow the agent or the system to operate better. But why the reason it's not correct is because if you think about it, if you're just going to bombard the context window with redundant tokens, you're going to be penalized. You're going to be penalized with hallucinations because the agent can get poisoned, right, with irrelevant data, and it just costs you more. And there's no reason for it to cost you more with redundant tokens. I'll take it to what we do at Tavily. So think about the question like, what's Leo's Messi's wife's name, right? You're going to get her Wikipedia page, but if you're just going to throw the entire Wikipedia page into your agent, into your prompt, you're just losing money. You're getting a lot of redundant tokens there, and it can cause hallucinations. So our job at Tavily was not only to get you to the right links, it's also to go inside and do processing that we're going to talk in a bit to make sure that we give you the minimum amount of tokens to allow you to answer the question or allow the agent to answer the question. And at the scale of the internet and the scale that we're seeing with AI agents, it's a difficult job to do because you've got to do it fast. Now, I'm going to take a step back about Tavily just so you understand how fundamental web search is and where it comes. So you're going to see a lot of verticalized agents, right? You're going to see sales agent, you're going to see marketing agent, HR agents. I'm not sure which one you invested in. I hope you're going to get rich. But eventually, all of them are going to need web search. The HR agent's going to go to LinkedIn, right? It's going to find talent. And the legal agent can go to the web to check for presidents online. But essentially, the scale that we're seeing right now, and we're seeing with the growth of the company, is insane. And we're just at the tip of the iceberg. Because every company is building their agentic system, and all of these verticalized agents are going to go into the same functions that people do today. As I mentioned, sales, HR, legal. All right. Let's talk about the dynamic split. So as we said, context engineering is about inserting the right relevant context at each step of the agent. Now, we also said that it's not RAM. You don't need to put 100%, to fill 100% of the context window. Every step can be different. Let's take a research agent, for example. So you're going to start with doing a lot of web research, right? You're going to collect data about the topic that you're exploring. But then you're going to take that, and all you want to do is to create an outline. So first step can be a very long knowledge, right? And very short and simple instruction. Just build me an outline. The next step, maybe you're going to split it, and you're going to write paragraph 1, 2, and 3. So for each one of them, the knowledge is going to be much less because you're going to split it, right? It's going to be less knowledge about the topic, and maybe you're going to have a lot of instructions. You can say you want MLA, APA, Chicago. Yeah, I just graduated. So you're going to give it a lot of instructions, less information, and it's the same agent, just different step. So you got to make sure that when you're building context engineering systems, you need to allow dynamic split between the 3 components. Awesome. So that I actually took from Lance Martin from LangChain. If you didn't read his blog or watch his YouTube video, he does have a great explanation about context engineering. Let's break it down one by one. So writing context, you should think about it much like people. So if you're going to listen to a lecture and you're going to have an exam after that, you want to write notes. You want to make sure that you're going to remember certain things that you listen. And what it allows you is you don't need to fill in all the context window. You can write it into your file system, and then you can retrieve it at certain different steps, right? So you can think of Scratchpad as something that runs with you throughout the same process, the same agent. You can also have long-term memory. So you know how sometimes if you use ChatGPT or any different chat application, it suddenly remembers something you talked about a few days ago. So that's really the long-term memory, which can be memories that are relevant or facts that are relevant for the system as a whole. Maybe it's going to be a different agent, different user at a different time. So think about a sales agent that is doing something bad and it lost a deal. If there's going to be something similar later with a different salesperson or a different client, you want to make sure that the agent remembers what went wrong and it can actually take it into consideration when writing the output. So that's how you should think of the long memory. Let's go into select, and that's reg, right? With select, you're going to retrieve information from the same component we mentioned. Either it's going to be a scratch pad, or it's going to be long-term. It can also be web data from Tavily. And here it's an art. And I'm going to say that for companies, the most important thing is to learn how to do it. Because system can be very complex. You can use different databases. You can use different communication methods. And no one's going to build it for you. No one's going to build something off the shelf that knows how to retrieve from whatever you want. It's not going to work, and that's why companies should put a lot of effort into just learning how to do it on their system for their agents. It's got to be very customizable to really get good results. The third part is compress context, right? So with compressing, that's probably the fun part, all right? And I'm going to tell you something that happened to us at Tavily. You can make it simple, right? You can just, if you have too much context, you can summarize a page, right? It should work, but it's not always working. Let's think about an article, a soccer game article, right? Which we retrieved from Tavily. I can know, based on the data we have, that 99% of the questions that's gonna be asked about this page is what's the result of the game, right? And if I know that, why would I just summarize the page? Maybe I would just choose the right chunk to return. So you have many different methods for many different use cases. And again, not everything is, again, you cannot always do semantics. Maybe you have financial data. Maybe you have, maybe you're working about people. Not everything is semantic, and everyone just usually fall back to this embedding methods and chunking and embedding. It's not always the solution. Think about coding agents, that not everything is semantic. So you gotta think and be very creative with the ways you compress and trim. Isolate. So I actually started with an open source called GPT Researcher. It was one of the first agents that went to the web, collected data, turned it into a coherent report. What we did there, which was pretty unique, is that we took a lot of data, and then we split it into a lot of mini agents, sub-agents, and we allocated each of the content of the knowledge based on the paragraph that each of the agents was writing about. Why it's so good? Because first of all, you're going to get, if you're going to have 5 sub-agents, you have 5 context windows, right? So you can actually do much more in parallel. It also prevents context poisoning. So if you're going to retrieve knowledge from a knowledge that only discusses about what you want, you have less risk of poisoning the agent with irrelevant data. And that's something that's not only efficient because you're doing parallel compute, but it also prevents a lot of hallucination and speeds up the process. Awesome. So we're going to do a very simple demo. So what you're seeing here is a master agent, the AWS Bedrock. We're going to use Claude. You're going to see 2 tools, right? 2 sub-agents. One of them it's going to use Elastic. It's going to go to a pre-filled CRM, a lot of dummy data. And it's also going to go into Tavily. And what we try to mimic here is an agent that's going to get a question about a client, right? It's going to be assistant for salespeople. It's going to check first, if it decides to, it's going to check on the internal data to check communication, it's going to check notes from salespeople, maybe it's going to talk about recent deal or updates, and then it's going to take all of this context and it's going to go outside to the web. Why do you want to go outside to the web? Maybe there was an announcement. Here at reInvent, we saw a lot of announcements, so we want to make sure that we're on top of everything. You can generate an email, hey, congrats on the recent fundraise, we want to sell you an office. So that's the reason you want real-time data. And yeah, let's see it in action. Awesome. All right, so what we're doing here, we're going to set up 2 tools. One of them is the Tavily web search. As I mentioned, now with Tavily, what we're trying to do is really to simplify everything for the developer. So the tool is 1 line of code. The agent already knows exactly what to do. And that's all you need to do when you define a tool with Tavily. The second thing is we're going to define the Elasticsearch tool, right? That's a method that LangChain are using. You can define the details about the tool right here. So it knows exactly, the model can know exactly what to do there when it goes into, when it chooses the tools. A lot of things that you shouldn't worry about, but that's how we define the tool. And we're going to set up using AWS Bedrock. We're going to set up the Cloud Sonnet, right? And now look how simple it is. Not that simple, all right? So what we're defining here is a very coherent set of instructions that really tells the model, the reasoning model, what to do. So we defined everything. So we defined the system prompt, your research agent that can conduct comprehensive, accurate, and up-to-date research using a combination of real-time public data and internal enterprise knowledge. So we're going to define the Tavily web search tool. We're going to define the vector search, which is the Elastic, and we're giving it all of these guidelines. Awesome. And what you're seeing here is also a pretty important, not pretty, very important concept about instruction, which is a few-shot learning. This is a one-shot learning, but you, as long as you can, you want to provide the model with a good, roughly relevant example on the process, on what to do, which directs the model much better. I'll give another example from real life. So we were trying to build a good search for coding agents, right? And what coding agents need is fresh data from documentations, right? You want to see the latest API updates if there was any change, so you're going to reduce a lot of hallucinations there. What we did, which was pretty smart, usually with APIs, if it's a new API, which we're seeing a lot today, and it wasn't trained on it, it's going to be really difficult for the model to do it the right way the first time. So we really want to make sure that you provide some example, and the more similar, the better it's going to get. So what we did was pretty interesting. So if there was a failure, we had a collection of examples from APIs, different APIs. If it failed, we would make sure to take it in the background and to generate another example that is very similar to the one that didn't work. And then the next time it ran, it would run a vector search on the collection of this example of coding snippets from each API, and slowly it learned and was able to improve over time and get the right few-shot learning, the top 3, and that allowed the model to always improve the execution with the new APIs. So that's what you're seeing here. It's an example, a question, thought, action, observation, and now let's see it's running. So what we ask here is check the Amazon deal size and find the latest earning report for them to validate if they're in the spending spree. So it's gonna go, soon we're gonna see all the thought process, but it's gonna go into the CRM, into Elastic. It's gonna find the relevant information from Elastic, from an Amazon account. And then what it's gonna do, it's gonna take it, it's gonna go to the web to find the recent earning report, and it's gonna generate a robust report based on that. I have a great Wi-Fi here, so it's oops. Yeah, no Wi-Fi. We're gonna upload it, so you can run it, so sorry for that. We're just gonna look at the output of the first one, just because it's there. So what you can see here, the question was, search for the latest news on Amazon relevant to our current CRM data on them. So what he did eventually, he thought, I first need to search our internal CRM data to understand what information we have about Amazon, and then search for recent news. Action, it went and understood it needs to go to the Elasticsearch. And after it got the results, the feedback which went into the knowledge, it decided on an action based on the other tools that it has in the instruction. And the next tool was the Tavily search. So it decided to search for Amazon latest news, AWS Cloud, AI Enterprise Partnership, 2025 months advanced news. Got the information, decided to do another search, and ended up with a coherent report about AWS. Awesome. So that's it. Yeah, we're on time. Thank you, guys.